Hello. Today we will start our week 2 lecture, project scheduling and tracking. So here's showing you that this study is done by the Statish Group. Statish Group is an independent international IT research advisory firm founded in 1985, and known from their report that 70% of the industry project over budget and behind schedule. 52% of all projects finish at a significant higher initial budget, and some project huge investment, but still not finished. Never finished. So this is a major concern for any software project is a budget and the schedule. We want to keep the project within the budget and finish the project on time. So this comes to the two major elements one we consider in the project planning. So before we dig into the detail how we do the planning, we want to look into the reason why projects are late. So here we have two topics: scheduling. That's what we will discuss today, and the next week we'll discuss the project estimation, the cost. So we split into 2 weeks to discuss the project planning. So the first one is the project schedule and why projects are late. The first reason is unrealistic deadline established by someone outside the group. The group here we are talking about is a technical group. A lot of times the decision of the deadline is not determined by technical group, it's by the marketing team or by the management team. So usually they don't consider much technical difficulty the group involved. What they're looking at is from the marketing point of view. One famous example is a Samsung Note 7. We know that Note 7 released on August 19, 2016, and 2 months later, in October 2016, the Note 7 was discontinued, and for the reason, the technical fault, because they have a battery issue, the battery explosion and hurt people. And then the later report showing that if they have more time, they can figure out the problem. Which means if they release the product later, they have more time to check the product, and then they don't have to discontinue. They can use a different battery vendor. They can solve the problem. But why not? The reason is the iPhone 7 will release on September 7th of the same year. They want to release 3 weeks before iPhone. So that's a marketing decision. It's not. This deadline is not. This release date is not set by the technical group. It's by the management. So if the deadline is not realistic, then it's not just a project will be late, and the project as a whole can be a failure. The second one is a changing customer requirement not reflected in schedule changes. So this sounds like very obvious. Why? So how come this happen? But if you ever involve any like a big project in a software company, you may face this problem because the requirement is done by a team, architecture is done by a different team, and detail design by another team, and testing by testing group. So you will see that there are different group involved, and then they may have some communication issues, especially when the requirement will go back and forth and back and forth, and if the later change requirement may not be reflected in a design, not reflected in the schedule. That's very common. So if you don't have a commitment to trace the requirement all the way from the requirement to the testing, then you will have this issue. The third one is underestimate effort and the resource required to do the job. This one, so here we will practice the lab 1 and 2, and you will practice this. You will practice have a task and then assign the resource to the task. So when you first doing that, and you may not have a quite clear idea how many resources needed. And that's not, and this is true not just for you, and it's true for for any manager, when they're doing the planning, they may overlook some risk. Yeah, they may underestimate the effort, and any predictable or unpredictable risk ignored during the planning. So there's also a very common technical difficulty cannot be foreseen in advance. And the next one is a failure to recognize the project is falling behind the schedule. So usually when we have a schedule, I mean the project planning done, and then we define the milestone, and by each milestone we need to look back to see the progress of the project. Is behind the schedule, ahead of schedule, what about the budget? So to do that, we have some metrics to telling us, like we use value analysis. Is some metrics will tell us the progress of the project. So if you don't do that constantly, then you may not realize the project is already over budget or you're already behind the schedule. Yeah. So this is something we will discuss today. Miscommunication among the project staff result in delay, and the change of the requirement not reflected in the schedule change is one of the miscommunication. There's many other miscommunication as well. For example, like a change in the architecture, or change for the interface for some component, and then if you don't communicate with the other component that will talk to this component, then that will cause some chaos, and then as a result the project will be late. And some human difficulties that can be foreseen in advance, especially the key staff, the key person turnover, get sick or hit by a truck, or just found a better job and leave the company. That will also cause the delay of the project. So these are the primary reason why projects are late, and some can be avoided and some cannot, like the human difficulties. This is something you cannot avoid. Like but something can be avoided, like failure to recognize. If we have a milestone and then we just follow the procedure to checking back, and then this can be avoided. So today we'll spend some time here. As the second, the later of this lecture, we'll see how we can and what metrics will help us to keep track of the project. The next is project scheduling. I showed you these slides last week. So basically, the scheduling involves defining all the tasks and then showing the interdependency of the task, identify the critical paths and the critical task, and ensure delay is recognized regularly. So these are our objectives when we do the project scheduling, and we will practice this in our lab. The scheduling principle, there are 7 of them. The first one is a compartmentalization. So the project must be compartmentalized into a number of manageable activity, actions, and tasks. And then we need to identify the relationship between the tasks, so-called interdependency of each task, action, and what task must be determined, and some tasks must occur in sequence within others can occur in parallel. So some tasks can have a sequential order, and some tasks can go in parallel, and some action and tasks cannot commence until the work product produced by another is available. Yeah, for example, like the testing. Yeah, so you cannot do the testing before the code is available. So the testing is always after code is available. So you will see there's a dependency. Some tasks depend on the work product produced by another is available, and then each task to be scheduled must be allocated some number of work unit. In addition, each task must be assigned a day, assign a start date and a completion date. So that are a function of interdependency, and also we make sure that whether the work will be conducted on full-time or part-time basis. So this will also we need to consider the full-time and the part-time when we allocate time for each task. The next is effort validation. So we need to ensure that for any given day there are enough staff member assigned to complete the task. So as time allocation occurs, the project manager must ensure that no more than the allocated number of people have been scheduled at any given time. For example, let's consider a project that has 3 assigned software engineer person day available per day for the of assigned effort. However, on a given day, there's 7 tasks must be accomplished, and each task requires 0.5 person day of effort. So this means we need 3.5 person day for that day. However, I have only 3. We have only 3 software engineer person day available. So here the available is less than the resource we need. So when we do the effort validation, well, when we done the planning, we must checking every task to make sure that the task has enough resource, enough staff member. Now if we use Microsoft project, it will highlight the task that will use more people than the resource assigned. So that's very good. The software will help us, the planning software will help us to do the effort validation. And then what's the solution then? If you need more resources than allocated, either you allocate more resource, adding more people in there, or if you are willing to pay overtime. So that's why in the planning tool, there's a standard rate, a standard salary, and also there's overtime salary. So if you are willing to pay the overtime and the software engineer are willing to take overtime, then you can accommodate this this issue. The next is define the responsibility, and people must be assigned to a task, and their responsibility and how they involve in the task. And for each task must come with an outcome, like the work product, the requirement. You must have a requirement specification document. So here I have some work products so that we can check against. Then we know we can verify if the person actually finish the task. And then the next principle is define the milestone. The milestone is a time. So basically, it's showing you showing you the major progress, a major progress of the project, so that by that milestone we can look back to check how well we done. One common mistake of all software team, the project manager make is to misunderstand the number of people involved and the project schedule. So they think adding people to a project will shorten, will improve the productivity, so that can catch up if the project is late. But in reality, is adding people to a project after it's behind schedule often causes schedule to slip further. The reason behind is the software project is the number of person involved and the productivity is quite complicated. Let's look at 2 extreme examples here. Okay. So in the real world, there are 2 extreme cases. One is the project can be done in parallel without communication between the people involved. For example, in a farm, in a strawberry farm, and then to harvest the strawberry, the more people you hire, and then the more productivity it is. If you hire just one person, it will do like this way, then come back, and then come back, all the way to finish harvesting the entire farm field. If you have more people, then 2 people can do in parallel. One people working on this on this line, and then the other working on this line. They don't have to talk to each other. So they just do the work. So the more people you have, the more productive you are. So in this case, the productivity and the number of person has a linear relationship. The more people you have, the more productivity you have. So for this case, the reason of this linear relationship is that they don't need to talk to each other, and they don't have the task depend on each other. They can do strictly parallel. So that's why the more people you have, the more productive you have. And then in the real world, there's another extreme case. No matter how many people involved, the productivity remains the same. Can you tell me what kind of example like that? Yeah, I can give you one example, like having a baby. Okay, having a baby taking 9 months. Yeah, no matter how many women you have, still taking 9 months. You cannot say, okay, I have nine women, I can have a baby in 1 month. That's impossible. So in that case, why we need 9 months? Because the task cannot do in parallel. So you have the one step and strictly follow another. If it is a strictly sequential task, then no matter how many people you have, you still take the same amount of time to finish the task. In the software engineering, in the software project is something in between. It's not linear, and it is not a horizontal line. It is something in between, because some tasks we can do in parallel. So when we do the coding, for example, we can decompose the software into different components so that you can assign people working on the different subsystem or component at the same time. That's a task can be done in parallel, just like picking up strawberry. But some tasks have to come in an order. For example, like without finishing the requirement, you cannot do the design. Yeah, so design must the architecture come after the requirement. So you have some sequential order. But for within the task, for example, like in the design, in the testing, I can do in parallel. So here is a mix of the sequential and the parallel. So the productivity of the task, the productivity of the software project is a weird shape. It's not a straight line, and it's not a horizontal line either. So this telling you that when the project is late, adding more people may not be efficient. So the best solution is do that in advance, because when you add in new people in there, and the new people need some training, need to get familiar with the environment, and then to keep everybody on the same page, and the new person can contribute. You need to allocate a resource to train the new person and to talk with the new person. That all take time. So but when the schedule is very tight, then this that little time you spend on new person will cause the schedule to sleep further. So that's the reason we do not add a person to a project when the project is already late. Okay, this effort distribution table showing you that will help you when you design your project plan. We see that the front end activity, including the customer communication, come up with the requirement specification, do the planning, analysis, architecture design, and detailed design, and doing the review, and then going back to change the design, then review again. So this process that we call the front end activity account for up to 50%. The construction activity, the coding and code generation is only in 15 to 20%, and the testing will take 30 to 40%. You will see that most effort is spent on two ends, the front end and the testing and the maintenance. Basically, we're taking 30% and 50%. The writing the code only take 15 to 20%. So this may surprise you. You may think writing code is the most important part in a software project. Actually, the front and the testing taking more effort than coding. So this gives you the project scheduling steps. We have 6 steps here, and the highlighted one are the one we are going to discuss. The work task breakdown, showing the statistical structure of the task, and defining task network, show the interdependency of the task, and then identify the critical paths and tracking, and the last is n-value analysis. So the highlighted part are what we will discuss today. First is why we need work breakdown structure. So the work breakdown structure gives you the statistical structure of all tasks involved. Not all projects have WBS, so WBS stands for work breakdown structure, and it's true that some of these projects have been successful. They don't use WBS but still successful. But why? But why is a WBS is needed? And so we have already looked at a few examples. But so the WBS will especially when you work for a company or organization that has many projects being performed simultaneously, and each of the project is competing for limited resources available, and then the WBS will enable you to review project detail and distinguish one project's need from another within the company or organization. So basically, if you have a WBS, your project will be highlighted. It will be highlighted, and then you will have an advantage to compete the resources. So the WBS usually come with a structure, have a hierarchy, 3-level hierarchy, even more level hierarchy, show the relationship of all the tasks needed for a project. So this is the first task. We show the statistical relationship of all tasks. The next, once we have the task, we need to confirm, we need to perform. The next is to assign who is responsible. So to assign the responsibility, we usually use this responsibility table. So this table tells that on on the left column is a task. Is a task involved, and then the first line is a team involved. And the latter is the responsibility of each team. For example, like an interview note, we have these 1, 2, 3, 4, 5. We have 5 teams involved, and each team has their responsibility, has a different role. And then each letter shows how they involve in this task. So here, I is called information, A is accountable, R is responsible, and C is consulting. Or you can just give a different, a role. So this depends on your company and your team. You can have, you can define different role. But this table is very important. So here we know that who is responsible for what and for what kind of responsibility they have. The next task is to have this activity table. So for each task from the WBS, we give a code. It's just like ID. So you either start with ABC or like a 1, 2, 3. So you usually start with number. Right? Like the A. Then for each task, you have an immediate predecessor. So this shows that to review the catalog, you have to draft the catalog, in order to review. So here, the task B depend on cannot start until the until the product from A become available. So A is the immediate predecessor of B. So similarly, E's immediate predecessor is D. So here we can use this table to show that the interdependency between the task, and then we can translate this activity dependency table into a graph, the so-called task network. Let's look at one concrete example here. Suppose here we have activity from A to J, and then we have the immediate or required predecessor. A and B have no predecessor. This means that A and B can start immediately. Without depending on any product. And C and D depend on A, C, D, E depend on A, and F depend on C, G depend on D, H depend on B and E. So this means H cannot start before B and E are finished. I depend on H, and then you cannot start J without finishing F, G, and I. And the third column is the duration, means how long it takes for each task to finish. So this 5 can be 5 days, 5 weeks. So this any time unit you define here. So here is a duration. Then we can translate this activity table into activity network. So here, like A and B can start immediately. So in the box, we have A, and then 5 shows that how long it takes to finish. So A take 5, for example, 5 days to finish, and then B take 1 day to finish, and A and B can start without any predecessor. And then C, D, E depend on A. So once you finish A, you can finish C, D, and E. And C take 2 days, D take 3 days, and E take 2 days. And then after finishing C, you can working on F. F takes 3 days, and G take 4 days. And once you finish B and E, then you can working on H. H take 2 days, and I take 1 day. And once you finish F, G, and I, then you can work on J. J is the last task, take 1 day. So in here, we know that the task, the project started with A or B and finish with J. And the highlight here, you may wonder what's the highlight. Highlight here is the critical path, and the task on the critical path are called critical task. And why they are critical? So we know that the project take from A or B to J, and how long actually for the project to finished? There's 4 possible paths. Path 1 to path 4. Path 1 is A, C, F, J, and this path take 11 days. And P2 is from A to J, is from A, D, G, J, and this take, when you add them up, it takes 13 days. And P3 is A, E, H, I, J. If you add the duration up, it is 11 days. And from B to J is B, H, I, J, take 5 time unit, 5 days. So from here we see the P2 take the longest time, is 13 days. So the P2 is identical to the project duration. So the critical path take the longest time, and that's the project finished. That's identical to the project duration time. In other words, if any task is delayed in here, the whole project is delayed. For example, if task A takes 6 days to finish, then the whole project take 14 days to finish. So you have 1 day late. If G4 take like a 6 day to finish, then the whole project take like 15 days to finish. So you'll see that these are the critical paths we don't want to delay we don't want this task be delayed. So if other tasks being delayed, yeah, it's okay. Like the C is delayed. Like C take 3 days to finish, it's fine. C can take up to 4 days to finish. Yeah, because you see that this allowance, there's a 2 days difference. So this shows the task C and F each can take 1 additional day to finish without affecting the entire project. So this is a critical task. Critical path is a very important concept in the software project management. So once we have the task and figure out the interrelationship and the duration of each task, the next task immediately after that is to figure out the critical task, because this critical task you do not want to delay. You do not want this task taking more time. Otherwise, your project will be late. And also, I mean, for the other task, you will see that how much allowance they have. Yeah, like the P4 is a B. Yeah, and I mean the has only 5 time unit. Only 5 time unit. So like a BHI, you can just take time. Yeah, you have 8 days. You have 8 days, 8 additional days to working on this. So when you allocate the resource, and then you can allocate less resource in BHI and allocate more resource in ADGJ. So that's when we figure out this critical path, I mean the critical task, then when you assign resources, you know where to assign more resource. Let's working on this class exercise. So here I have this activity and the required predecessor and the duration. So I want you to draw the activity on node, activity network, and identify all possible passes, and then calculate the duration of each pass, and then identify critical paths. So let me telling you that a similar problem will appear in your midterm exam. Please follow these steps. Yeah. So first draw the network, and then identify the path and the calculate duration of each path, and then identify the critical path. Please follow these steps. So this shows that once you show each steps, and if you make a mistake in some step, and of course then your final result will be wrong. But if you follow the steps here, you will get most of the point. If you skip all the paths here, the steps here, and just showing me the critical path, if your final answer is wrong and without any intermediate steps, and then you will lose all the point. Yeah, so here, please follow the step to finish. This class exercise. Okay, so I will give you 10 minutes to do that. So if you can finish this in 10 minutes, you are in good shape. Yeah, you're in good shape. So the next slides show you the solution. So here is the activity network, and then I highlight this is a critical path, and of course there are many possible passes, and you need to do the calculation, and the answer is AEHK. And I hope you get the right answer. Okay. The next is using the Microsoft project. Here I assume that you already installed Microsoft project. The Microsoft project is only working for Microsoft Windows. So if you use a Mac machine, then please install a virtual machine in Mac, a Windows virtual machine, so that you can use Microsoft project. And then here, I won't go to the slides here. Instead, I will go to the lab, because the lab is going to use a Microsoft project. Okay, this lab, you're going to use Microsoft project, and the lab is assigned is coming Thursday, and you have 1 week. You have 1 week to finish the lab. So this the lab 1 and 2 combined. The lab 1 is you're working on a schedule, and lab 2 you're working on the cost. So you can start working on the lab 2 next week. So here. The lab actually requires you to develop a project plan for software system described below. So here is a customer description of desired software, and then you use Microsoft Project to plan a 3-month project using today as the project starting date. So using the September 9th, September 10th as a starting date. Yeah, so today is you assume today is Thursday. Yeah, Thursday. September 10th as a starting day, and finish in 3 months. So September to October, November, and December. December 10th. December 10th is the finishing date of the project. And you got a total budget of $1 million. So for this week, for this week, what you try to do is to customize the plan to make 3 months. And the next week, you're working on the budget part to make a $1 million budget. Okay. So the task asks you to use software development template. So how I do that? So in here, you start with a new. When you open the project, you start with a new, and then you can search for the template. You can search for the software. You can just search software. Then software development plan will show up. And then you just open it and create the starting day. As I said, the starting day is September 10th. So you make September 10th as your starting date, and then you create. Then you will see that the default project finish on January 21st, and you want to make this one be December 10th. You cannot just change data here, and this won't work because this one is the add up of all the subtasks. So you'll see that for each category. And if you go in here, you will see that they have a detailed task of each category. You cannot just change the category here. For example, this one take 21 days. You cannot say, okay, this one will take 20 days. This won't work. Yeah, this won't work because this one is the adding up is automatically calculated. Is automatically calculate the date. How many days needed in this category. So to change the data here, you have to change each one of them. You have to change each of them, then this one will add up. This one will add up. Okay. And then which task should I change? So this is all up to you. So in here, you just keep one thing in mind. Remember when we discussed the critical path, the first thing you need to do is to identify the critical task. So only when you change the duration of the critical task, then the total project duration will be changed. If you change this task, then this won't change. Yeah, because this task is not affected. It won't affect the total the project duration. So in here, you need to figure out which tasks are critical tasks, so that when you change that task, the duration changed. How to do that is I will leave the question to you. There's a way to do that. Yeah. One way I can show you, is to go to the network diagram, and the highlight one, the one in red, are critical tasks. So in here, you know which task is critical. So you see the ID is 14. Then you go back to the Gangnam view, and then you go to the task 14, and this one is a critical task. Yeah, critical task. So this is one way to do that. There's another simple way to do it. I leave to you to figure out. In other words, in order to make the total project in 3 months, in 3 months, you first identify critical tasks and then change their duration. Yeah, for example, like this one, if I change to 11 days, then you will see that, well, there's no change. Yeah, there's no change. Oh, yeah, there is change. So basically, you identify the critical task and then you change their duration. Then you will see the finishing date changed. So the final finishing date should be December 10th. Okay, so this is a Microsoft project. So in here, the timeline is a Gangnam view, and there's a different view you can have. Yeah, so here, the resource view. There's different view. So here I ask you to explore different view. The resource view. So is when you go to the project, and in the view, you see here there's a resource sheet view. This is resource view. Okay. So this shows you the team member you have, and also their standard rate. So initially there's only all of them are 0. Of course, that's incorrect. So you need to put the hourly rate here and the overtime rate here. So here you need to put so since here are 0, then the project will cost $0. So here you need to have a $1 million. Then you have to pay them to do. If you pay them 0, then the total project will take $0 to finish. So here is one way to change one way you can adjust the total budget. And here you will see that the person in red. Now, why these persons are red? This shows this person are overused. So this means you assign this person in more a task they can handle in a day. So here I leave this question. I leave this task to you. So when you're working, so in the Gangnam view here, hold on, why is not showing? Okay. You see that here shows that the task so this is where the this person are overused, and so when you change this, assign this one to more resources, and also to more team member, then you can share the burden of this one person, so that this person will not be overused. In your final deliverables, when you show me the resource, the resource table, I don't want to see any red. So to do that, you need to add more resources. Of course, for this project, it takes 3 months and $1 million. That's a lot of dollars. So you need more team member, and then assign the task to more than one people. You cannot just assign to one person, assign to more than one person, so that will share the load of one task. That's how you massage the. That's how you massage the total budget. So these two views in here is one, the guideline view, the resource view, and the task usage, the calendar view, the network of the diagram view. So these are quite straightforward. So in here, you just go back to here and go to the view. You see that you have network view, you have a task usage view. It is other views also has a calendar view. Let me see where's calendar. Oh, here you have a calendar view. So basically, I want you to explore the view and show the screenshot of this. Okay. So these 4 views, and then generate 4 and 5 report, and one of them must contain the total task. I mean the total cost. So if you go back to the project, you will see this report. There's so many reports you can do, and one of them is the cost. So here, so you just show. Yeah, for example, like, let me see the one of the task cost overview. Now the cost is 0 because their salary is 0. That's why it's 0. Okay, so here I want to see that it's $1 million. It's $1 million here. Okay, so you export the different report. I want to export 4 to 5 report, and one of them contain the total cost. And then when you submit your report, you submit as a zip file, and the zip file contain one is the Microsoft project file. If you once you finish it, you can save. Yeah. So you can save this Microsoft project file. So I need this project file, and also I need a report showing the description and a screenshot of the view here and the report. So here your this week lab is to shorten the project to 3 months, and the next week you're working on the resource and assign to the different people to make 1 million. So here you have 1 week to finish this lab 1 and 2. As for the customer description of desired software, so for the lab 1 and 2, you can ignore it, because what you have is a generic software project. So this plan can apply to any software project. So what you need to do is to delete some task and add some task, and change the duration of the task, and then that's how you massage the duration of the task, and assign to different resources. That's how you manipulate the budget. So here the working on here is actually disconnected to the detail of the project itself. Yeah. The reason I put in here is the same customer description will apply to a term project. So you and your lab. Let me see. Your lab 6, 7, and 8. You're going to practice UML. To the requirement, to the class diagram. So this part, you will use the same description here. So the same description. So basically, you are going to design a EGOT. You're showing the class diagram of the EGOT. So here I give you the customer description in the second week. So then you can start to think about it. Start to think about how to design the software. So the lab 1 and 2 is just working on the plan. So even without the description of the software, you still can finish this task. Okay, let's go back to. So here we explore different view. The next topic is project tracking. So here, imagine you already finished the project planning and you define the milestone. The next is to keep track on the project progress. So to track that, so this vertical line is the milestone is a milestone date. So this is a planned cost, and then by the milestone we look back and we see the actual cost. Then we can check the progress is in terms of budget and the schedule. So to do that, we need to use the n-value analysis. It's a measure of project development progress and enable us to check the both budget and the schedule. In order to do that, we introduce three basic terms. BCWS, the budgeted cost of work scheduled, and actual cost work performed, and then budgeted cost of work performed. BCWS, ACWP, and BCWP. By calculating these three basic metrics, we can calculate these three basic metrics by the time of a milestone. We can check the progress of the project. Okay, so BCWS. So just by reading its name, we know that is a planned cost of the total amount of work scheduled to be performed by the milestone date. So the BCWS can be done once we finish the planning, because these one are the scheduled task and the budgeted cost. Actual cost of work performed, by reading its name, we know there is a cost incurred to accomplish the task that has been done to date. And the BCWP is a budgeted cost of work performed, is not the actual cost, is a planned cost of completed cost that has been done. Then let's look at it. So once we have these three metrics, how we can evaluate the progress of the project. So in here we have two. One is the BCWP, the budgeted cost of work performed, and the actual cost of work performed. So both are targeted work performed, and one is the budgeted cost and one is the actual cost. So from here we know that we are comparing the cost. The red one is the actual cost, and the blue one is the right cost, and this apply to the work performed. Then we see that actual cost is higher. So this shows the by this time the project is slightly over budget, is 7,000 over budget. If we put the budgeted cost of work performed and the budgeted cost of work scheduled, when we put these two together, we see that the work performed is less than work scheduled. So what does this mean? Does this mean we save money? No, the answer is no, because they are both budgeted cost. And one is performed and one is scheduled. So this shows the work performed is less than work scheduled. This shows that we finish less tasks than supposed to. Yeah, because both are the budgeted costs, and one is performed and one is scheduled. The performed is less than scheduled. So this shows that we accomplish less tasks. This shows we are behind schedule. This is not showing we are saving cost. Yeah, we are not saving cost. I mean, we deliver less. We finish less task. We are behind schedule. So when we put this whole thing together, we can see both. The budget and the schedule. So there's some derived metrics from these three basic metrics. The one is a schedule variance, is BCWP minus BCWS. So a negative variance means the project is behind schedule. You see that this one both are budgeted costs. So this is how I memorize it. I see this both are budgeted costs. So we are compare the work performed and the work schedule. So the work performed, if work performed is less than work schedule, then of course the project is behind schedule. So this is the schedule variance. And the cost of variance is BCWP minus ACWP. They are both work performed, and they are calculated is I mean that what they compare is the budget cost and actual cost. So if this one is negative, means project is over budget. So because the work performed is the same. So this is how I memorize this. So in the exam, you are of course, our exam, we can have everybody sitting together and then do the exam. So that's not feasible. So you have to take a home exam. So please, you don't have to memorize this formula, but you must understand. You must understand this. So in our previous example, we can calculate the schedule variance and the cost of variance. So this one is 6,000. It means we are behind. We are behind schedule of the work that the work of the value 6,000. The cost of variance means we are 7,000 over budget. And then we have more derived metrics, the schedule performance index, the BCWP over BCWS. So if this one is less than 1, means behind schedule. Similarly for the cost performance index, BCWP over ACWP, if this one less than 1, means project is over budget. And then we have a CSI. So for the higher manager, but they're more interested in the CSI. The cost schedule index is a product of CPI and SPI. So CSI is a CPI times SPI. So we want this number larger than 1. If this number is less than 1 and the further is from 1, the less likely the project will recover. So the project cannot recover. So here is a very important index, and the top manager are interested in this CSI. Let's look at this class exercise. So here, this this take-home exercise. I want you to finish this at home, and assume you are a software project manager, and you have been being asked to compute invariance statistics for small software project. The project has 56 planned tasks, and that are estimated to require 582 person day to complete. At the time that you have been asked to do the unvariant analysis, 12 tasks have been completed. However, the project schedule indicates that 15 tasks should have been completed. And here, showing you the schedule data in present day are available. So here we have a task. By the time when we do the analysis, we are supposed to finish 15 tasks, but actually we only finished 12. And here is a planned effort, and here is actual effort. And you're asked to calculate the schedule performance index, schedule variance, the cost performance index, and the cost variance for the project. So in order to calculate this index and the variance, we need to calculate three basic metrics. So how to calculate that? Then let's okay, let's open this open here. So here we have a table. Okay, we have a table here. By the time when we do the unvalue analysis, we are supposed to finish 15 tasks. But in reality, we only finished 12 tasks. And this column is budgeted or planned cost or effort. So here 12 all the way here. So I skip some of the skip the number in between. Okay, so these are taken from the table, and then this is the actual effort or actual cost of this 12 task. And then can you tell me what is a budgeted cost work schedule? How to calculate budgeted cost work schedule here? And this one is the actual cost of work performed. And this one is a budgeted cost of work performed. Okay, so budgeted cost of work schedule. So we are scheduled to finish 15. We are scheduled to finish from 1 to 15. And the budgeted cost is planned cost. So the budgeted cost is the summation of all 15 plan effort. So this one is from 1 to 15 because of the work schedule is supposed to finish 15. So 1 to 15 planned effort. Yeah, you add up this 1 to 15. This is budget cost of work schedule. So what is actual cost? Work performed. So work performed is only 12. I perform only 12. And actual cost is actual cost here, is actual effort here. So in here is the actual cost of work performed is you add this 12 together. Is 1 to 12. Yeah, because perform is only 12. Actual effort, what cost here. And the budgeted cost work performed. So work performed is only this 12. Is only this 12. The budgeted cost is the planned effort is here. So budgeted cost is 1 to 12. Planned effort. So these are three basic metrics. Then you can bring these three basic metrics into the formula here to calculate the schedule variance, cost variance, and this schedule performance, cost performance index, and cost schedule index. I mean, calculate these three index. So here I show you the formula. Yeah, I show you the formula how to do this, and similar problem will appear in your exam. In order to calculate this derived matrix and index, you need to calculate these three basic metrics, and you know how to. I hope, yeah, I want you to understand how to calculate these three basic metrics. Okay, yeah, please follow the steps. Yeah, to do that, calculate these three basic metrics and then calculate derived metrics. So this implies that even your derived metrics calculation is incorrect, as long as your formula to calculate these three basic metrics is right, and then you still get some point. Okay. Okay, I think that's it for today, and I will see you Thursday. So Thursday our lab starts at 4 p.m. So lab is synchronized. Please join the Zoom at 4 o'clock. And since already post the lab on Canvas and also post this video, so you can start working on the lab before the lab start, because basically you have a 3 days, 2.5 days to working on the lab before you come to the lab. So I hope you can bring your question to the lab, and then we can discuss together. Okay, I will see you Thursday.